one of the more important equations of this unit is the ideal gas law. So the ideal gas law is derived from all the other gas laws we just talked about, and it just boils down into PV equals nRT, where P is the pressure, V is the volume, N is the moles, R is the universal gas constant, and T is the temperature in Kelvin. So the value of R differs depending on what unit of pressure you chose. I always like to choose kilopascals, and I remember the value of R is just 8.314 if you're using kilopascals. If you're using atmospheres, then 0.08206 is your unit of R, and torr is 62.37. So let's do an example. N2O2 is used in dental procedures to keep patients relaxed. It's also known as laughing gas. So a cylinder of N2O has a volume of 20 liters and is under 308 kilopascals of pressure, 294 Kelvin. We want to know how many grams of N2O are in the cylinder. So PV equals nRT. Just plug everything in as you have it. Just rearranging gives us this for the number of moles. Notice that our ideal gas law doesn't say anything about mass, so we need to find the moles first, and then from the moles we can find the mass. So we get 2.49 moles of N2O. If we plug it into mass equals moles times molar mass, we get the mass as just 110 grams of N2O. So quickly, let's talk about Dalton's law of partial pressures. So Dalton's law of partial pressures just says that the total pressure of a cylinder or of a balloon or of any body that you're looking at is equal to the pressure exerted by all the gases in that body. So PT equals PA, which is one gas, the pressure of one gas, PB, which is the pressure of another gas, and so on, depending on how many different gases you have in that container. You can also just rearrange that and get the partial pressure of any one gas, PA, is equal to the mole fraction of that gas times the total pressure in that cylinder. So over here I have an example. We have a container filled with pressurized air, and it has a pressure of 801 kilopascals. If the air is 20% oxygen, we need to determine the partial pressure of oxygen. So it's just a very simple calculation. The partial pressure of oxygen, PO2, is equal to the percent of O2 times the total pressure in the container. So we have 0.2 as in 20% times 801 kilopascals, and that gives us 160 kilopascals is the pressure, the partial pressure of just oxygen.